Hello everyone. So आज आपण हाय परफॉर्मन्स कम्प्युटिंगचा 6 युनिटचा सेकंड पार्ट कव्हर करणार आहोत, which is these topics. So frameworks. HPC has a lot of frameworks. So the framework selection criteria is as follows. Requirement काय आहे, डेव्हलपमेंटची एक्सपर्टीज काय आहे, परफॉर्मन्स कॅरेक्टरिस्टिक्स म्हणजे परफॉर्मन्स कसा पाहिजे, and support and community and integration capabilities. So these are the frameworks: software platform for distributed computing, abstract away complexity of parasystems, provide programming models and runtime environments, enable efficient resource utilization. So, definition. So these are the frameworks. First one is Kubernetes, quite popular in cloud computing. So open source container orchestration platform, automated deployment, scaling and management of containerized application developed by Google, now maintained by CNCF. So if any of you have used Docker or Podman, then you might know what I'm talking about. So basically containers काय असतात, एक small virtual machine असते without any of the bulk. Like जुन्या virtual machines मध्ये खूप bulk असतो operating systemचा, त्याच्या dependencies. But containers are really lightweight and we can clone them very easily. So तुमच्या ॲप्लिकेशनवर वर्कलोड जास्त आला, ट्रॅफिक जास्त आली, so we can deploy multiple containers of that application and that will reduce the load. So key features: container orchestration. So एवढे सगळे containers podsला हँडल करण्यासाठी Kubernetes आहे. So container orchestration, service discovery, load balancing, self-healing. So if a container fails, it can fix it. And secret and configuration management. So kahi variables we don't want to be public, so we can also handle that, and also handle the secrets. And storage is important. We have multiple containers त्यांचे वेगवेगळे data nodes आहे. So we have to automate and orchestrate storage also. So this is the architecture. We have a control plane inside a cluster. We have nodes, and inside nodes we have pods. So let's understand this one by one. Master node, so basically the one who is handling everything. So is the control plane of the Kubernetes cluster. It manages the overall state of the cluster, and it consists of several components. API communicates to all other tools. etcd, distributed key value store, configuration इथे store होता. Controller manager, responsible for managing controllers that regulate the state of the cluster. Scheduler, so if we have some, I don't know, application that we want to run at a particular time, suppose we have to take backups of our data, म्हणजे daily backups घ्यायचा एका टाइमला, so we can put it in scheduler. Worker nodes, so these are the nodes who actually do the work, like जे मी म्हटलो virtual machines आहे छोट्या छोट्या lightweight, these are the workers which are orchestrating everything. Kubelet is managing the state of container, so the container state Kubelet handle करतो, and it communicates with the API. Then kube proxy हा virtual network setup करतो त्या virtual container साठी. And then we have our container runtime, जिकडे containers actually run होता. So that was those things. आता pod हा सगळ्यात बेसिक प्रोसेस आहे. A container might contain multiple pods. So a Kubernetes pod is a group of containers deployed together on the same host. So pods operate on one level higher than individual containers. and these groups of containers work together to operate for a single process. My bad, मी थोडं मिक्स केलं. पॉडमध्ये मल्टिपल प्रोसेस आहे आणि मल्टिपल प्रोसेस in a pod, and in a single pod there are multiple containers. So थोडं कन्फ्युजन होऊ शकतं. So kindly read through it. So single containers थोडं वरती आहे pods. Pods provide two different types of shared resources. So networking and storage is shared as because multiple containers are there, we have to share resources. आणि त्याचा स्वतःचा एक IP ॲड्रेस असतो, कोड असतो, स्टोरेज रिसोर्सेस असतात. So these are objects, deployment, services, images, volumes. Volumes are storage, namespaces are virtual clusters. Config map and secrets are sensitive information. Services are abstracted to expose applications. Deployments, pretty self-explanatory. Resource management apply करायला लागते, CPU and memory request according to limits. You have to define की कधी क्लोन करायचे कंटेनर्सला. So we have to define all that. So now we have Docker, a platform for developing, shipping, and running applications in containers. So Docker is another platform. It is mostly used for single containers. So त्याच्यामध्ये हे components आहे, Docker engine, Docker images, Docker containers, and Docker registry. Engine म्हणजे जो मेन Docker engine आहे त्याच्यावर सगळं चालतं आहे. Images म्हणजे टेम्पलेट्स आहे कंटेनर्सचे. एक स्क्रॅचपासून बनवण्यापेक्षा प्री-बिल्ट टेम्पलेट्स असतात विथ डिपेंडन्सीज. डॉकर कंटेनर, नॅचरली द ॲक्च्युअल ॲप्लिकेशन, अँड रजिस्ट्री जिथून आपण हे डॉकर इमेजेस अँड कंटेनर्स डिस्ट्रीब्यूट करू शकतो. सो दीज आर द बेनिफिट्स. देन वी हॅव अपाचे स्पार्क, which is fast in memory data processing engine. So हे डेटाबेस पाइपलाइन्समध्ये इम्प्लिमेंट होऊ शकतो. Provides rich APIs in Java, Scala, Python, and R, built around the concept of resilient distributed databases. The key components are as follows. As I said, database related आहे, so SQL NLs. Mongo नहीं है ये याच्यात. So Spark Core, Spark SQL, and all that. Machine learning पण आहे, MLlib. Then we have Hadoop. This is for distributed storage and processing. Built around MapReduce, जे आपण आधीच डिस्कस केलं होतं. So it has all these core components: Hadoop distributed file system, yarn, yet another resource negotiator, MapReduce, and its modules. Now let's talk about GPU applications. Okay, so GPU, graphic processing unit, त्याचे काय application होऊ शकता. Originally developed for rendering graphics, कारण CPU वर खूप लोड येत होता पूर्वी. So we just design a different type of component for graphic rendering, hence the name graphic processing unit. So GPU versus CPU. GPU मध्ये thousands of simple cores, ideal for data parallel tasks. CPU मध्ये fewer complex cores, better for control intensive task. GPU task हे हाय अरिथमेटिक टास्कसाठी बरे असतात आणि हायर मेमरी बँडविड्थ असते. Then we have GPU application fields and use cases. So these are the use cases. Finance, pretty important. Large data sets आहे आणि खूप सारे मॅथमॅटिकल कॅल्क्युलेशन्स आहे, सो सिम्युलेशन्स पण आहे. So GPU is a naturally occurring use case here. Data science, imaging, machine learning, no introduction needed here. Media and entertainment, so आपण जेव्हा व्हिडिओ एन्कोड करतो तेव्हा व्हिडिओ एडिटिंग करतोय मी आता. सो दॅट रिक्वायर्स GPU because videos, if we split them, they are literally a grid of pixels. आणि encoding decoding मध्ये we need large amount of cores for it. So GPUs are used there. Then we have different GPU programming modules. So CUDA, we have seen it, used it, and it is good, but it is proprietary. फक्त NVIDIA's GPU वर तो चालतो. Then we have OpenCL. So this one is open source and it works across CPUs, GPUs, and other processors, ARM processors too. Then we have Direct Compute, which is DirectX. त्याचा एक खूप चांगला एक्झाम्पल आहे जेव्हा आपण विंडोजवर गेम्स इन्स्टॉल करतो. Those games need direct compute or DirectX. So 9, 10, 11. So it is used there. GPU architecture and execution module. So like we have seen in previous units, these are the components. So streaming multiprocessors, SMs, CUDA cores, memory hierarchy. So global memory is the slowest but the biggest. Shared memory is between, and registers are the fastest with the lowest amount of memory. त्याच्यानंतर specialized cores, tensor core, RT cores. जसं RTX मध्ये रे ट्रेसिंगसाठी RT cores वापरतो आपण. Then we have execution module. So single thread, single instruction, multiple threads, blocks, grids. So yeah, that's pretty much it for this. So optimization techniques are here. I won't go deep. So shared memory, avoiding multiple threads working on the same task. You should distribute it properly. Duplication नहीं होना पाहिजे. And so on. Then parallel computing for AI ML. So as I said की AI ML मध्ये large amount of arithmetic operations होत असतात. Matrix multiplication, for example. And we also need to divide large problems into smaller subproblems. So it is a naturally eligible use case for AI and machine learning because of the data volume and complexity. Real time लगता है आपल्याला. And the training time also reduces. So again the same thing, GPU acceleration होतं because we are using thousands of cores, multiple layers, single global shared memory. The ability to perform matrix multiplication in parallel allows deep learning models to be trained much faster than traditional CPUs. Specialized hardware, NVIDIA tensor cores, AMD matrix cores, Google tensor processing units, which we can efficiently utilize using TensorFlow library, and custom AI accelerators. Then we can also use distributed computing. So just like I said, TensorFlow, Apache Spark, PyTorch, breaking the workload into smaller pieces and the multiple machines मध्ये आपण distribute करतो. So data parallelism, model parallelism, training optimization, synchronous, and all that. Multi-threading, FPGA. These are deep topics which we won't go much into. Cloud computing for AI ML. So Amazon Web Services, Google Cloud, Azure हे सगळे AI ML वर्कलोड्स रन करत असतात. त्यांना एवढे मोठे वर्कलोड्स रन करायला पॅरलल कम्प्युटिंगचा नॅचरली यूज लागतो. So specialized hardware like GPUs and TPUs can be used for various operations, auto ML capabilities, APIs, integrated data processing pipelines, and much more. So these are the frameworks: TensorFlow, PyTorch, These are the ones I know. Others I haven't used that much because I'm not much into those areas. But yeah, these are the ones. Okay, so these are the case studies for HPC. वेदर फोरकास्टिंग मध्ये कसं HPC यूज होऊ शकतो. सो वेदर प्रेडिक्शन मध्ये we need to perform a lot of mathematical calculations. So that requires massive computational power. We need those prediction fast. So low latency and high memory. आणि IO हँडल करायसाठी पण GPUs are quite useful. So parallelization approach बघू शकतो आपण. रिअल वर्ल्ड इम्पॅक्ट काय होतो की accuracy increase होते कारण GPUs are much more accurate in double precision data than CPUs, and we can model the predictions in all scenarios. So that is that. Then genomics research. So DNA sequencing. DNA is quite tedious. Like it's quite heavy because इकडे जसं मेन्शन केलंय, it contains petabytes of data. So gigabytes, 1000 gigabytes is terabytes, and 1000 terabytes is petabytes. So DNA sequencing is one of the more intense, storage intense application. So त्याच्यामध्ये HPC लागणारच आणि एवढा मोठा data. We can't really run it on a single computer or a single core. So we have to implement HPC right here with GPUs. Then drug discovery, same as DNA, large amount of data need to speed up exponentially. And also neuromorphic computing. So इकडे आपण ब्रेनला सिम्युलेट करतोय, kind of useful for AI and scientific simulations. So these are the case studies, and that is pretty much it for this unit. This unit was quite boring to explain, also to research, but we have to study it. So that's it for HPC Unit 6 and HPC in general. So if any questions, please ask away. And if any doubts, queries, suggestions, please mention it in the comments. And please subscribe. We are really close to 1,000 subscribers. And thanks for watching. We'll see you in the next one.